The National Electrical Code, or NEC, made pole and handrail bonding a code requirement in approximately 1999. This means that electrical codes started to mandate the bonding of metallic parts associated with swimming pools to ensure electrical safety. Bonding is a critical safety measure that aims to minimize the risk of electric shock in and around swimming pools. The purpose of bonding is to create an equipotential plane, meaning that all metallic parts in and around the pool area are at approximately the same electrical potential. This reduces the voltage difference between these parts, preventing dangerous electric shocks. Before 1999, bonding requirements may have existed in some local jurisdictions or specific applications, but it wasn't a widespread requirement in the NEC. The introduction of mandatory pole and handrail bonding in the NEC reflected a growing awareness of the potential hazards associated with electricity and water. Swimming pools present a unique electrical risk due to the presence of water, which is a good conductor of electricity, and the close proximity of people to electrical equipment and metallic structures. Several metallic parts around a pool require bonding. These include the pool's reinforcing steel, often referred to as rebar, metal light fixtures, metal ladders and handrails, metal diving board supports, and any other metallic structures within a specified distance of the pool. The bonding process involves connecting these metallic parts together using a solid copper conductor. This conductor creates a low impedance path for electrical current to flow, ensuring that all bonded parts are at approximately the same voltage potential. The size of the bonding conductor is determined by the NEC and depends on the size of the service entrance conductors or the overcurrent protective device. The general principle behind bonding is to minimize voltage gradients in the pool area. A voltage gradient exists when there is a difference in electrical potential between 2 points. If a person comes into contact with two objects that have different voltage potentials, they could experience an electric shock. By bonding all metallic parts together, the voltage gradient is reduced, minimizing the risk of electric shock. The NEC specifies the methods and materials to be used for pool bonding. These requirements cover the size and type of bonding conductors, the methods for making connections, and the location of bonding terminals. The code also addresses the bonding of underwater lighting fixtures, requiring them to be bonded to the pool's bonding grid. The installation of pool bonding systems should be performed by qualified electricians who are familiar with the NEC requirements. Proper bonding is essential for ensuring the safety of swimmers and other individuals using the pool area. Periodic inspections and testing of the bonding system are also recommended to verify its effectiveness. It's important to note that bonding is different from grounding, although the two concepts are often related. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to flow back to the source in the event of a ground fault. Bonding, on the other hand, is the process of connecting metallic parts together to equalize their electrical potential. While bonding and grounding serve different purposes, they both contribute to electrical safety. In addition to bonding the metallic parts of the pool structure, the NEC also requires the bonding of any electrical equipment associated with the pool, such as pumps, filters, and heaters. This equipment must be bonded to the pool's bonding grid to ensure that it is at the same electrical potential as the other metallic parts. The bonding grid is typically a network of interconnected copper conductors that runs around the perimeter of the pool. The bonding grid is connected to the pool's reinforcing steel, as well as to any other metallic structures in the pool area. The bonding grid helps to equalize the electrical potential throughout the pool area, minimizing the risk of electric shock. The NEC also addresses the bonding of pool decks. If the pool deck is made of concrete or other conductive material, it must be bonded to the pool's bonding grid. This helps to prevent voltage gradients from developing on the deck, which could pose a shock hazard to people walking around the pool. The bonding requirements for pools are constantly evolving as new technologies and materials are introduced. It's important to stay up to date on the latest NEC requirements to ensure that your pool is in compliance with the code. One of the most important things to remember about pool bonding is that it is a safety measure that should never be taken lightly. Improper bonding can create a dangerous situation that could lead to serious injury or even death. If you are not familiar with the NEC requirements for pool bonding, it's best to consult with a qualified electrician. A qualified electrician can inspect your pool's electrical system and ensure that it is properly bonded. They can also make any necessary repairs or upgrades to bring your pool into compliance with the code. Pool bonding is an essential part of pool safety. By following the NEC requirements for pool bonding, you can help to protect yourself and your family from electric shock. Here are some additional details about pool bonding according to the NEC. Firstly, all metal parts of the pool structure, including the reinforcing steel, must be bonded together. Secondly, metal parts of electrical equipment associated with the pool, such as pumps and filters, must be bonded to the pool structure. Thirdly, metal parts within 5 feet of the inside edge of the pool must be bonded. Fourthly, the bonding conductor must be solid copper and of the correct size, as specified in the NEC. Fifthly, connections must be made using approved methods and connectors. Sixthly, the bonding system must be tested to ensure that it is effective. Seventhly, the bonding system should be inspected regularly for damage or corrosion. Eighthly, any repairs or upgrades to the bonding system must be performed by a qualified electrician. Ninthly, the bonding system must comply with all applicable local codes and regulations. Tenthly, it is important to remember that pool bonding is a safety measure and should not be taken lightly. Proper bonding helps to equalize electrical potential, minimizing the risk of electric shock. The general requirements for equipotential bonding are found in NEC section 680.26. The bonding requirements aim to establish a common electrical potential among all metal parts in and around the pool area. The equipotential bonding grid must extend at least 3 feet horizontally from the inside walls of the pool. This creates a zone of equal electrical potential around the pool, reducing the risk of shock hazards. Specific items that need to be bonded include metal parts of the pool structure, metal fittings, metal parts of electrical equipment, metal conduit, and metal piping. The bonding conductors must be copper and sized according to NEC Table 250.122. The bonding connections must be made with listed bonding connectors suitable for direct burial. The resistance between all bonded parts must be less than 1 ohm. This ensures that there is a continuous electrical path between all bonded parts. Regular inspections and testing are recommended to verify the integrity of the bonding system. Any damaged or corroded bonding connections should be replaced immediately. The NEC also specifies requirements for bonding of pool decks. If the pool deck is made of conductive material, such as concrete with metal reinforcement, it must be bonded to the equipotential bonding grid. This helps to prevent voltage gradients from developing on the deck surface. The bonding conductor for pool decks must be copper and sized according to NEC Table 250.122. The bonding connections must be made with listed bonding connectors suitable for direct burial. The resistance between the pool deck and the equipotential bonding grid must be less than 1 ohm. The NEC also includes requirements for perimeter bonding. Perimeter bonding involves installing a copper conductor around the perimeter of the pool, typically buried in the ground. The perimeter bonding conductor must be at least 8 American wire gauge solid copper. The perimeter bonding conductor must be buried at a depth of at least 18 inches below the ground surface. The perimeter bonding conductor must be located within 3 feet of the inside walls of the pool. The perimeter bonding conductor must be connected to the equipotential bonding grid. The purpose of perimeter bonding is to extend the zone of equal electrical potential around the pool. This helps to prevent voltage gradients from developing in the surrounding area. The NEC also addresses the bonding of metal fences and other metal structures near the pool. Any metal fence or structure within 5 feet of the inside walls of the pool must be bonded to the equipotential bonding grid. The bonding conductor for metal fences and structures must be copper and sized according to NEC Table 250.122. The bonding connections must be made with listed bonding connectors suitable for direct burial. The resistance between the metal fence or structure and the equipotential bonding grid must be less than 1 ohm. The NEC also specifies requirements for bonding of underwater lighting fixtures. Underwater lighting fixtures must be bonded to the equipotential bonding grid. The bonding conductor for underwater lighting fixtures must be copper and sized according to NEC Table 250.122. The bonding connections must be made with listed bonding connectors suitable for underwater use. The resistance between the underwater lighting fixture and the equipotential bonding grid must be less than 1 ohm. The NEC also includes requirements for bonding of metal conduits and piping. Metal conduits and piping that contain electrical conductors or that are connected to electrical equipment must be bonded to the equipotential bonding grid. The bonding conductor for metal conduits and piping must be copper and sized according to NEC Table 250.122. The bonding connections must be made with listed bonding connectors suitable for the type of conduit or piping. The resistance between the metal conduit or piping and the equipotential bonding grid must be less than 1 ohm. The NEC also specifies requirements for bonding of metal ladders and handrails. Metal ladders and handrails that are within 5 feet of the inside walls of the pool must be bonded to the equipotential bonding grid. The bonding conductor for metal ladders and handrails must be copper and sized according to NEC Table 250.122. The bonding connections must be made with listed bonding connectors suitable for the type of metal. The resistance between the metal ladder or handrail and the equipotential bonding grid must be less than 1 ohm. It is important to note that the NEC requirements for pool bonding are complex and can be difficult to understand. If you are not familiar with the NEC requirements, it is best to consult with a qualified electrician. A qualified electrician can inspect your pool's electrical system and ensure that it is properly bonded. They can also make any necessary repairs or upgrades to bring your pool into compliance with the code. Improper pool bonding can create a dangerous situation that could lead to serious injury or even death. Therefore, it is essential to ensure that your pool's electrical system is properly bonded according to the NEC requirements. Always consult with a qualified electrician for any electrical work related to swimming pools.